Welcome to another informative series on electric motors. In today's video, we will be looking at everything that is needed to know about servo motors. That is the part that made up these motors, and their applications. So let's get started. A servo motor is a type of electric motor that rotates with great precision. It is a rotary or linear actuator that allows precise control of angular or linear position, velocity, and acceleration of the rotor shafts, which is in turn usually connected to the load.
These motors have been around for a very long time and are utilized in many applications. They are usually smaller in size when compared with other motors of the same rating. But this type of motor is packed with a big punch torque and they are very energy efficient.
Servo motor can also be known as a device that uses electrical input to generate mechanical output like velocity, acceleration, or position in a controlled way. The controlled features that this motor has allowed the motor to track objects within a moving conveyor, moving robotics arm, and it is used extensively in filling machine and other rotary equipment.
This motor is divided into the following part, which are the motors, the controlling circuits and the feedback system. Motors come in two forms, which are AC motors and DC motors. AC servo motors are used for high torque applications while DC servo motors are used for low torque applications.
Also, it is on the basis of this that AC servo motors are used for high-speed applications, while DC servo motors are adaptable to limited-speed working conditions. Operation-wise, AC servo motors have smooth, stable, and less noisy operation, while DC is known to be less stable and has a noisy operation.
Although the noise and stability issues are less with AC motors. But overall, there is a common complaint with servos from the market regarding these issues in both AC and DC servo motors in general. That is, they sometimes make an undesired growling noise. This problem can be eliminated by reducing the gain on the speed controller. However, lower speed controller gains can lead to an increase in position error and a decrease in needed performance.
Of course, instability in a motor is uncontrolled and unintended motion at the motor shaft. That is the additional shaft rotation that happens at low or high frequencies. Again, the instability at higher frequencies is the audible growling sound that is heard. This instability is caused by excessive gain in the speed controller of the drive. The gain setting of the speed controller determines how much torque the drive will generate. For this reason, the gain value should be directly proportional to the inertia of the connected load that is seen by the motor shaft. So overall, by constructions, the servo motor consists of a rotor and a stator. The rotor is made of permanent magnets, while the stator consists of wound coils. So the rotor will continue to chase the electromagnetic field, but it will never be able to reach it.
By constructions, it can also be known as a synchronous motor or induction motor. But preferably, it is usually a synchronous motor, which is because the rotor is made of a permanent magnet.
With the magnetic rotor, this will result in high torque coupled with motion-sensing devices.
Servos are controlled by sending an electrical pulse of variable width, or pulse width modulation, through the control wire. There is a minimum pulse, a maximum pulse, and a repetition rate. A servo motor can usually only turn 90 degrees in either direction for a total of 180 degrees movement. The motor's neutral position is defined as the position where the servo has the same amount of potential rotation in both the clockwise or counterclockwise direction. The pulse width modulation that is sent to the motor determines the position of the shaft, and based on the duration of the pulse sent via the control wire that the rotor will turn to the desired position. The servo motor expects to see a pulse every 20 milliseconds, and the length of the pulse will determine how far the motor turns. For example, a 1.5 milliseconds pulse will make the motor turn to the 90 degrees position. Shorter than 1.5 milliseconds moves it in the counterclockwise direction toward the 0 degrees position, and any longer than 1.5 milliseconds will turn the servo in a clockwise direction toward the 180 degrees position.
The pulse sent can either be in form of a digital or analog pulse in nature. So in order for the motor to rotate at a particular direction, then pulses need to be sent.
In Lean-man terms, pulses can also be synonymous with frequencies. That is, when a frequency of a particular range is set, the motor rotates in some degrees in a clockwise direction. However, at negative frequency, the motor rotates in the anticlockwise direction.
Feedback system consists of a sensory devices that track the angular displacement of the shafts as it rotates. This device is also known as an encoder. So what it does is to simply send a varied signal back to the servo drive or controller. This will communicate the measured value, and these values are voltage, velocity, current, torque, acceleration, or positioning. These encoders are typically integrated into motors or loads.
This positional sensing device is what makes this motor to be a little bit different from the other type of motor we have in the markets.
So on a lighter mode, the combination of position sensing devices and some other devices is what is known as servo mechanism. So, servo mechanism is basically a closed-loop system, consisting of a controlled device, controller, output sensor, and feedback system. The term servo mechanism most probably applies to the systems where position and speed are to be controlled.
So, servo motors can properly be defined as a closed-loop electric motors that produce constant speed and precise angular positioning of the shafts.
Yes. Servo motors are specially designed to be used for remote-controlled or radio-controlled toy cars and airplanes. Servo motors are also used in industrial applications, such as robotics, inline manufacturing, pharmaceuticals, and in food and beverage industries. In the coming series, we will be looking at steppers motors. The way this motor works will be looked at, and their applications. Hope you have learned something new today. See you in the next one.